So in vectors, the first thing we are going to deal with is the magnitude. So given the vectors A is I minus 3j plus k, and the vector B is minus 2i plus 3j plus 2k, and the vector C is 3i plus 4j minus k, determine the magnitude of the vector D, which is A plus 3b minus 2c. So we want to use this example to explain the concept of getting a magnitude of a vector, isn't it? So a magnitude of a vector is just the length of a vector. Are we together? So if you have vector A, the magnitude of vector A, for instance, if you have a vector here, if this is your two-dimensional vector space, if this is a two-dimensional vector space, and you have this vector here, maybe this is vector A. Are we together? So if you want the length of this vector A, you will see vector A as the y component and the x component. So if here is x and here is y, meaning this length here is the whole of this length from y to 0, that is 0, the origin is y, from here to here is x, because all vectors are relative to the origin, meaning they originate from the origin, isn't it? So if you want the length of this vector, you can see this is a right angle triangle, meaning the length of this vector is the magnitude of that vector given by the Pythagorean theorem, meaning the magnitude of vector A. If you have vector A, you can see it is from O to A, meaning vector A, instead of denoting O to A, vector A is relative to the origin, meaning from O to A gives you the length of vector A from O to A, isn't it? Which is simply denoted as vector A. So if you're looking for this length, it is the Pythagorean theorem, and you can see that is the hypotenuse, isn't it? That is the hypotenuse. So, if this hypotenuse is the magnitude of vector A, the magnitude of A is denoted as that. You put those signs of absolute value. That is how we denote a magnitude of a vector. So if this hypotenuse here, let's say maybe it is r, then you can see the Pythagoras theorem. There we have r squared is equal to x squared plus y. Are we together? So if you find the square root on both sides, you end up with r is square root of x squared plus y squared, isn't it? Is that okay? So r is the length of this, giving you the magnitude. So this r of magnitude of A is what we denote by that. So anytime you are looking for the magnitude of a vector, it is the Pythagorean theorem. So once you've seen the concept of magnitude from two-dimensional, meaning in three-dimensional, if vector A was in three-dimensional, was in x, y, z plane, then the magnitude of vector A would have been the square root of x squared plus y squared plus z. When it is three-dimensional. When it is two-dimensional, it is x squared plus y squared, isn't it? Now three-dimensional Pythagorean theorem will be what? X squared plus y squared plus z squared. So that is how to determine the magnitude of a vector. So let us go back to our problem to explain this concept. You've been given vector A to be I minus 3j plus k, isn't it? So you know a vector is in the form xi plus yj plus zk, the position vector, isn't it? So the position vector is always in the form xi plus yj plus zk, which can be represented in column form as xyz, isn't it? Are we together? So it means here, this is the position vector of any vector. So here you've been given vector A. You've been given vector A to be what? I minus 3j plus k. This is what you've been given as vector A, isn't it? Yes. So if you look at this, the coefficient of I is x, meaning you can see x is 1. Are you seeing that? The coefficient of j is y, meaning you can see y is negative 3. Are you seeing that? The coefficient of k is z, meaning you can see z is positive 1, isn't it? So this one is written in the form x, y, z, meaning x is 1, y is negative 3, z is 1. Have you seen? You've written the position vector A in column form. Are we together there? You move to the next vector, vector b. What have you been given there, vector b? Vector b you've been told is minus 2i plus 3j plus 2k. So in column form, you know it is x over z, isn't it? X is the coefficient of I. X is negative. X is negative 2. Y is the coefficient of j. Y is positive. Positive 3 is just 3, isn't it? Then z is the coefficient of k. Z is 2. Or positive 2 is just 2, isn't it? Then go to the next vector you've been given is vector c. So vector c you've been given is what? 3i plus 4j minus k. Then you know in column form x is the coefficient of I. X is 3. X is the coefficient of I, isn't it? Y is the coefficient of j. Y is positive 4. Positive 4 is just 4, isn't it? Then z is the coefficient of k. That is negative 1, isn't it? Z is negative. So we found A, B, C. But what do we want? We want vector D. Before we get the magnitude of vector D, we must get vector D first. Because we are looking for the magnitude of what you know. You cannot get the magnitude of what you don't know, isn't it? So you have to get vector D first before you get its magnitude. Are we together? So can we now get vector D first? What is vector D? Vector D will be told it is A plus 3B plus minus 2C. So we want to substitute the value of A, B, C. So where there is A, you put the value of A. Where there is B, you put the value of B. Where there is C, you put the value of C. So start substituting. What is A? A is the column vector 1, negative 3, 1, isn't it? Then it plus 3 into B. What is B? Negative 2, 3, 2, isn't it? Are we in order? Then it is minus 2 into C. What is C? 3, 4, negative 1, isn't it? So if you look at these column vectors, a column vector is just like a column matrix, isn't it? And when you can recall from matrix the scalar multiple, meaning a scalar multiplies all the elements of a matrix, isn't it? The scalar multiplies all the elements. So what do we have here? You simply go and you do it at once. You go to the calculator and you don't waste time. Go to the calculator. 1 plus 3 excess. You deal with the excess until you are done with excess, isn't it? So excess here we have x 1 plus 3 times negative 2 minus 2 times 3, then you get the x value. You do x on its own, y on its own, and z on its own. Are we together? We are trying to skip the step of saying that 3 is a scalar multiple. 3 multiplies all the elements inside. Negative 2 multiplies all the elements inside, so that we remain with positive here. Those are steps we can ignore, okay? So that we just say 1 plus 3 times negative 2, isn't it? Minus 2 times 3, meaning you are dealing with the excess for you to get the final x value. Is that understood? So for the x here, we have x here is 1, then we have positive 3 into negative 2, then we have minus 2 into 3. You are done with the final x value, isn't it? Then you go to the y's. What is y here? Negative 3. Then outside here we have plus 3 into y here is 3. Then we have minus 2 into y here is 4. You get the final y value. Are you seeing that? Are we together? You do the same to z1 plus 3 to z value minus 2 into z value, isn't it? What do you get? Start with the x. What have you found for x? This is 1. 3 times negative 2 is negative 6, isn't it? Then negative 2 times 3 is also negative 6, isn't it? So it is like you get negative 11. What do you have there?
Negative 11.
Negative 11. Are we together? Now, this is just for explanation purposes. This is just for explanation purposes, but there are a lot of steps you can always ignore, okay? Then you move to the next one for y, negative 3, then plus 3 times 3, then minus 2 times 4, isn't it? What do you get to be y? Negative 2. Yeah, because this is positive 9, this is negative 8, isn't it? That is positive 1 and negative 3, you get y to be negative. Go to z. Z here is 1, z here is 3 times 2, positive 6. Z here is negative 2 times negative 1, so that is positive 2. So positive 2 and positive 6, and you get z to 9. What have you found? Z is 9, so it means we can only get the magnitude of D when we have D. See, we found the D. And this D we found is what? See, this 11 is x, negative 2 is y, 9 is z, isn't it? So if you want the magnitude of D, the magnitude of this is the Pythagorean theorem, isn't it? So magnitude of this is the square root of x squared plus y squared plus z squared. You will have found the magnitude of D, x squared plus y squared plus z squared. That is going to be square root of, remember, you don't need to deal with the negatives in the calculator because you know negative squared will always be positive. So I don't expect you to go, because somebody will go and write negative 11 squared. This means you only squared 11, not negative. Are you seeing that? So it means you are supposed to have negative 11 squared plus negative 2 squared plus 9 squared. This is what you are supposed to have, so that when you open those brackets, you end up with 11 squared plus 2 squared plus 9 squared, because negative squared is positive. Negative squared is positive. So that is the reason why when I come here and just write 11 squared plus 2 squared plus 9 squared, it means I've omitted this step where I was opening the bracket. Are you seeing? Yes. Are you seeing that? Is that okay? So what do you get to be the magnitude of D? The square root of 11 squared plus 2 squared plus 9 squared. What do we have? You have 14? 14.35. So the magnitude of D you found is 14.35. So this symbols for absolute value is what denotes the magnitude. Are we together? And never forget to put the square root, because the square root, how did you get it? This side was squared, isn't it? And you were looking for the square root on both sides, isn't it? So that is how to determine the magnitude. Meaning anytime you are told to determine the magnitude of a vector, it is the Pythagoras theorem, isn't it? The Pythagoras theorem, and you are done. And you cannot determine the magnitude of the vector if you don't have the vector itself. Meaning you have to determine that vector first, isn't it? If they want vector D, you must get this D first. Because after getting it is when you see its x, y, and z value, isn't it? You have to get the vector itself. So that is the concept of getting a magnitude of any vector.